Assalamualaikum and good day to our lecturer, Dr. Farah. We are from Group 6. My name is ZULIQHA and my matric number is 198421. Today we'll be presenting for mini project EPF3304 in pitaya juice manufacturing. Okay, first for the introduction, what is process control? Process control is statistical and engineering discipline that deals with the design and mechanisms for maintaining the output of a specific process within a desired range to ensure a process is predictable, stable, and consistently operating at the target level of performance with only normal variation. It allows continuous process mass production as well as a level of automation by which a small team can run a complex process from a central control room. It minimizes the variability of finished products, which in this case is pitaya juice, in order to meet the regulatory requirements and the expectations of consumers regarding product quality and safety. It is aimed to reduce wastage and production costs by improving the efficiency of processing. The whole process of producing pitaya juice is receiving material, raw material, UV filtration treatment, cleaning or washing, peeling, extraction, mixing, filtration, hard filling, pasteurization, packaging, and chilling. Process control implement artificial intelligence which eases the production of this pitaya juice. I will be presenting about mixing process. Mixing is the process to make a heterogeneous physical system which is pitaya juice homogeneous by using manipulating operation. Mixing concludes the production process by combining concentrated juice and essence to achieve a desired juice blend. In the mixing operation, fractions of several concentrated juice batches are transported from bulk storage tanks to liquid-liquid blending unit. After the extraction process, the concentrated juice batches are blended to target a desired sugar to acid ratio as well as color. This ensures a uniform product is always formed. Additionally, essence solution and oils are added to recover flavor loss during concentration. The objective of this mixing process is to allow the juice mixed with other ingredients to achieve the desired concentration, colors, and flavor. After mixing, a uniform fruit juice product is ready for preservation and testing for quality assurance. Problem statement for mixing. Before it is pasteurized, the final composition of juice must consist of sugar, concentrated juice, edible acid, and essence to achieve a desired concentration and taste. Pitaya juice must undergo mixing process to ensure the composition of the juice are well mixed and reach the set point for concentration. Hence, controlling the flow rates of inlets in mixing is important to achieve the desired final concentration. So we proceed with control objectives in mixing. Maintain product quality. Mixing process is important in determining the composition and concentration of the pitaya juice, whether it applies to the set points or not. Thus, it is important to control the mixing process as it will affect the product quality if the inlet flow rates during mixing process is not controlled properly. Process variables for mixing. So the control variable is final composition of the juice. Manipulated variable is flow rates of the inlet. The final composition of pitaya juice, which consists of concentrated pulp of pitaya, water, sugar, essence, and edible acid, need to be controlled by adjusting the flow rates of the inlet to get the desired concentration and flavor.
Filtration is the removal of the solid particles from a fluid by passing the fluid through a filtering medium or stopum on which the solid are deposited. The fluid may be the liquid or gas filtering or removal a small amount of the solid to product or a clean gas or a speaking clean liquid such as behavior. Problems are bacterial control, maintenance problem, lack of the monitoring, and record keeping and equipments designing and uh, specifications. Safety, the of a safety meaning system is the provide a structured management approach to control safety risk in operation. Product quality. In order of the maintenance product quality, you must first know the process that product will undergo and the product specification that you must to achieve with and the products. You must also know the business product or the checking the quality and the parameters within your permitted work. During the process, you must ensure that all the health, safety, and the hygienic procedures and the follow at the all times, and the deviation from the normal is repent impolity to a censor member of the staff on approved action to taken. Main plotted variables is the input that the controlled by the process operated or controlled system. The main plotted variables are the adjusted by the process operator or controller system to keep the controlled variables in the system at the constant setting. And for the final P and ID, simple, can see of the upstairs for the dragon fruit put in the drink juice of the dragon fruit put in the tank, and after that is going to fill.
Hi, Assalamualaikum. My name is Muhammad FARHAN IMAN bin Yasni. My matrix number is 196805. And I will talk about the filling process. Filling process is the product where we fill our product into the container that we want to sell. So in this process, we use the hot filling process where the product and the bottle were preheated before it being used. The reason why we use this method is the hot filling process will make the shelf life of the juice become longer. So the hot filling process will undergo in temperature zone between 82 degrees C and 85 degrees C. The reason behind the high temperature is we want to sanitize we want the juice to sterilize the inner part of the bottle. The inner part of the bottle may inhibit some bacteria and some chemical at the wall, so we use the high temperature or hot juice to sterilize the inner part of the bottle, including its cap. So after the process has been done, the bottle will be chilled because the chilling process will help the juice to maintain its nutrients and vitamins. The hot filling process also use PET bottle. PET bottle is not like the normal plastic bottle because the normal plastic bottle may melt if you use the high temperature or the hot juice to sterilize it. So the PET bottle can withstand the hot temperature. Hot filling will help to sterilize the bottle before it being used because uh, the the inner part of the bottle may harm or spoil juice after it has been pasteurized. However, since the process operates at high temperature, it may cause some of the nutrients in the juice to degenerate. So, by controlling the processing temperature to a safe zone, which is mentioned earlier, around 82 degrees C and 85 degrees C, we can reduce the degenerated nutrients and making the bottle sterilized at the same time. Our control objective for the filling process is solely for ensuring the quality of the juice. Since the hot filling process operates at really high temperature, a transmitter installed into the filling machine so that staff can monitor if there is any significant temperature change. If there are many major increase to the temperature, it will make the nutrients inside the juice will degenerate, thus making the juice unhealthy. If the temperature is too low, the bottle will not be sanitized perfectly and may cause some bacteria to spoil the juice. The example of bacteria that may spoil the juice is Clostridium botulinum. For the process variables, the CV is the temperature of the juice filled in the bottle, and the MV is flow rate of the juice after pasteurization process in the tank. We choose the MV for the filling process as temperature because now we move to the process variables. Our CV is temperature of the juice filled in the bottle, while our MV is flow rate of the juice. The reason behind the CV and MV is for the MV, the flow rate of the pitaya juice entering the bottle because after the pasteurization process, pitaya juice is stored into a clean tank to cool it down a bit before filling it up into the bottle. For information, the pasteurization is at 95 degrees C. Our hot filling process will be operating at 85 degrees C, so we need to chill it down first. The flow rate of the juice may not be constant because the flow rate depends on the hydrostatic pressure of the tank. This hydrostatic pressure depends on the height of pitaya juice in the tank. Thus, the higher the amount of the juice inside the tank, the higher the flow rate of juice for the filling process. Next, for the CV, in this process, the amount of desired volume of pitaya juice in each of the bottle, which is 1 liter per bottle, and the temperature of the juice to fill into the bottle. But we are more focusing on the temperature of the juice. This is because we are doing hot filling process. So the juice will kill the bacteria inside the bottle. So we are more focusing on the temperature for the CV. And last, for the individual part, is the PI drawing. Here we can see the pasteurized juice from the cooling tank move into the tank for the filling process. And for this process, we use the feedback control system to monitor the temperature. If we detect any significant change in the transmitter here, so it will send signal to the pump in the for controlling its flow rate to control the temperature.
So next I will continue for the next process, which is pasteurization. So what is pasteurization process? It is a process of heating up the juice to below boiling point and then cool it quickly to eradicate microorganisms. It is done continuously, where the juice is pumped from the storage tank and fed into pasteurization process. The pitaya juice processing is designed to ensure that the juice remains at pasteurization temperature for the perfect time before it passes through the pasteurizer's cooling section. And high temperature short time HTST or flash pasteurizer is used, where the juice usually heated up to 72 degrees Celsius for around 15 seconds. The problem arises in pasteurization process as it helps to eliminate the decomposing organism in pitaya juice and passive enzymes that can cause chemical changes. However, heating may cause damage to the quality of the pitaya juice. Therefore, by controlling the temperature and the heating time, the effect on the quality of the juice can be reduced and able to achieve the effect of the sterilization. And this can be done by adopting high temperature short time pasteurization. So the control objective of this process is first to maintain product quality. The process is known to be very sensitive to heat and surrounding. The raw juice received will be easily spoiled if it is not handled correctly or if it does not undergo process following the requirement that has been set up. For example, if a pasteurization process is carried out at inappropriate temperature, it may cause the products to be unsafe for consumption because the microbes was not reduced at a safe level. Therefore, by applying control processing, the product's quality can be maintained and also the whole production can be run smoothly. And next is to optimize profit. Process control can monitor the stability and efficiency of the process. Usually, process engineer will take action before the process becomes unstable. Thus, the production rate will go back to usual that will earn the profit that the company aim for. And then the third one is for to ensure smooth plant and production rate. So process control is applied for almost each equipment for every process in production line. Engineer will able to do some adjustment before the product is produced. Therefore, it can ensure that the plant operation and production will run smoothly. So this is the PNID of pasteurization process using the equipment of plate heat exchanger. So based on the diagram, the control variable The variable to be controlled is the outlet temperature of pitaya juice of the plate heat exchanger, and manipulated variable is the inlet temperature of hot water. So in this diagram, the pitaya juice enter the first inlet while the hot water enter the second inlet. So in the plate heat exchanger, the hot water will heat up the pitaya juice and to desired temperature. After that, it will go to the cooling section to be cooled down before it flow out. It go out to the next process. Also, as seen in the diagram, the instruments that attached in the diagram was temperature transmitter and temperature indicator controller. This is because we want to control the the pitaya juice outlet by manipulating the hot water inlet.
So for my part, I will explain about the extraction process. So basically, extraction process is done by extractor machine to obtain pulps that will put into a spiral juice extractor. Inside the machines, there are knives that cutting the pitaya and a scraper that separating pills and pulps. A continuous plate or harness is a press where a pitaya pulp layer is squeezed between vertical plate movements, and the pitaya pulps which at the press end is distributed on a horizontal nylon bed with the same tissue as in the hydraulic press in press clothes. Next, the pitaya pulp and roughly extracted juice are conveyed to the next process and pills are discharged. So for extraction process, the problem statement, the problem may come from the decreases and increases of pressure that not following its standard to function. It is very important to control the pressure at hydraulic press at the extractor machine. For extraction control objective, first it is to maintain the quality of pitaya juice. Without proper control for extraction, it can affect the quality of the juice. The quantity of pulp may be higher that will differ the taste and texture of juice. The juice quality can be assessed from the amount of natural juice extracted, the total shelf life for that juice, and the preservation or deliverance from harm. For equipment protection, the control of pressure at extraction machine able to prevent any machine and devices at this process from broken. This plate use has its limit pressure. If there is too much pressure, the plate cannot support it and may be broken. Then it for profit optimization. Fruit juice containing high percent of juice from the fruit extractor is difficult for a company as this require high expense. However, it is possible and it can bring a high return to the business. As a result, a lot of demand and better quality for the juice 100% natural from this fruit. The problem is the consistency of pulp and juice without sufficient strategy control of the main process are unable to sustain. This is because during the process, disruption or error will occur. The consistency of the juice can be measured based on the extracted natural juice, their total shelf life, and the protection or delivery from damage. Finally, for safety, each company has a responsibility to ensure that it always look after the safety. Furthermore, good safety features must be available in extraction process to avoid accident during the process. The method of extraction is interrupted for and impact the entire process. in the event of any incident involving the system. The problem is the lack of safety feature can be improved to make extraction safer. So this is the PID for the extraction process. So the MV will be the pitaya juice extraction ratio. If the ratio is incorrect, it can change the texture and taste of the juice. While for the CV, the pressure of a hydraulic press, the pressure needs to be controlled, as if it is too high, the plate can be broken, and while if the pressure is low, pitaya cannot be extracted at a maximum value, so profit cannot be optimized.
As for mathematical models for pasteurization process, so beforehand the assumption is made steady-state energy balance is used as the basis for the derivation of the mathematical model. Overall heat transfer U is assumed to be constant, and the fluid exists only in the liquid phase within the exchanger. So the heat, the first equation was given based on the heat energy equation, where the density is where rho is density of the pitaya juice, Cp is heat capacity of the pitaya juice, lambda is thermal conductivity, Te the inlet temperature of pitaya juice, outlet is T out is outlet desired pitaya juice temperature after pasteurization process, and Qgen is the heat generation. So since the process is assumed to be a steady state, the heat energy is assumed to be 0. Therefore, it will give equation 2, and then subtracting equation 2 from equation 1 will give equation 3. So simplifying the equation 3 will give rho Cp dt over dt is equal to delta lambda time Ti apostrophe minus T outlet apostrophe plus Q generation apostrophe plus heat generation. This is simplified by using the value, the Ti apostrophe, T naught apostrophe, and Q gen apostrophe value at the below. So applying Laplace in equation 4 will give the equation as stated in equation 5, where in the initial steady state, we can assume that T apostrophe at 0 is equal to 0, and T apostrophe is equal to T minus T steady state is equal to 0. And rearrange the equation 5 in terms of T naught apostrophe as will give the equation as given, where T apostrophe 0, T O apostrophe s is equal to K over tau s plus 1 times Q apostrophe s plus 1 over tau s plus 1 times Ti apostrophe s, where K is 1 over lambda, and tau is equal to rho Cp over lambda.
Before we start question 8, we need the mathematical modeling first. So let's refer to the previous section where our math modeling is Ks plus 1 over tau s plus 1, where K is 1 over lambda and tau s rho C sub P over lambda. Since we cannot find the conductivity, the heat capacity, and the density of the pitaya juice, so we assume that the conductivity is 0.045, the Cp is 1.7, and the density is 1 1093. So after calculating, the K value is 22.22 and tau s 41291.11, and we subs back into the equation, we get 23.22 over 41291.1 s plus 1.
Now we move to the tuning method and controller. Before we start, from the equation obtained, we get all this k, tau, and data value. And from the after some simulation, from the PID simulator, we get this KC and PU. So this is all the result using Ziegler-Nichols method. We have P, PI, and PID, and it shows for P and PI stable, while the PID have some overshoot. Then this is using Tyrus-Leuben method. We can see using both controller PI and PID, it is no overshoot, and the time taken that is different in time taken to reach the process value, as the PI take a bit longer time than PID. So this is the using Cohen-Kun method using PI and PID controller, and none of this controller make it to make the process value to reach the set point. And now this is the using integral errors method using the PI and PID controller. So we can see integral errors also for both controller not really good for extraction process. So based on all the data we get, we using all the PID controller using all method, and we can see on the we can see that the Ziegler-Nichols have overshoot that is not good for percentage process. And for the Cohen-Kun method, it is a big problem, same with integral errors, that not that we suitable for this process, that is not we want. And Tyrus-Leuben show that it is what we want, that is suitable for this extraction process, as there is no overshoot and reach the process value in a shorter time. So in conclusion, for this all tuning method and controller, we decide the most suitable tuning method is Tyrus-Leuben method using PID, and because this method and controller ensure the process can reach the set point, not too slow, it is fast, and the process got no overshoot, as overshoot can reduce the quality of pitaya juice, because if the temperature during pasteurization is too high, it can reduce the quality of pitaya juice.
So for the stability, since we have decided that TLPID tuning method is the best, so we can use the KC value, which is 104. So for the stability, we look at the stability equation, which is 1 plus GC times GP times GA times GS. Where so we input all the equation and the value in the formula, and we assume that GA and GS is 1s since we are not mentioning it earlier, and GC is equals to KC, which is 1604. So after the calculation, we get that 41291S plus 1604. Supposedly that we do this in a table where we separate it in a row. Since it only has two parts, where one is multiplied by S1 and one is a constant, so and both of them is positive, so we assumes that we can decide that the tuning method for the pasteurization is stable.
Now we move to the robustness. So before we do that, we need to change the value of our K and tau theta. We change it by 25%, negative 25%, and positive 25%. So this is the value. Now we have the graph for the change with negative 25% and positive 25%. We can see that if there is change on the process parameter, this method still can function properly. In this scenario, which this change, these two graphs show that Tyrus-Lubin method can be considered robust. The tuning method is applicable even the process parameters change. It shows that this process still in stable condition.
Now let's proceed to the conclusion. To be concluded, maximization of profits and efficient process can be ensured through process control. In the industries, production of pitaya juice is in large scale, which involves a lot of technologies and machinery. It is ensure the optimum product quality that has been set is achieved as the process operating within the boundary limit to avoid the waste of products if the production does not meet the standard quality. For instance, pasteurization process is important to kill bacteria at certain temperature to a safe level for consumption in pasteurization process, which is our main process. In this pasteurization process, the mathematical model has been chosen and the transfer function unit has been developed. The tuning method used was Tyrus-Lubin to achieve stability of the process, while the type of controller selected is PID controller. Lastly, the industry revolution. Nowadays, artificial intelligence is widely used in the industry. Artificial intelligence is a technology where intelligence is demonstrated by machines, unlike the natural intelligence displayed by humans and animals, which involves consciousness and emotionality. Artificial intelligence is the ability of a computer or a robot controlled by a computer to do tasks that are usually done by humans because they require human intelligence and discernment. Process control applies AI technology especially in large-scale manufacturing as it eases the production and management of the unit operation in a manufacturing process. According to studies, these control systems make decisions that are customarily human and help individuals foresee issues or cope with problems as they arise. It can interpret data and use the data to improve decision making in a process. Artificial intelligence uses algorithms of real-time data which can improve the control system in the pasteurization process, such as the use of programmable logic controller (PLC) system in the plate sterilizer. During the juice pasteurization process, a proportional integrated derivative PID controller was also used to continuously measure the error value. AI is useful in this sort of control system and aid system too. Inner control loop tend to be control system with largely unconscious action to perform such things as unexpected response and other natural functionalities. It is called automated adjustment if the system is equipped for correction without the need to respond for human feedback. The idea was to use sensor to track the output value of the control system to provide feedback on input actuator that could correct those optimum performance. So, it is aimed to replace the old method with this new technology. So that's all from us. Thank you.